Ready? Okay, a study of National Football League retirees age 50 and older found, and that's the population of those retirees, found that 62.4% have arthritis. You randomly select or you ask 75 retirees who are at least 50 years and older. They have to fit that population. They have to be from that population, and ask them whether they have arthritis. What is the probability that exactly 48 of those 75 will say yes? So first thing we need to know, Stephen, is this binomial? Yeah. Why? Because why? You have a lot to say this morning. Come on, help me out. What's N?
No, I'm lying. It's 48. Right? No.
75. Thank you, Harande. Someone paying attention over here. Thank you. N is how many you ask. How many times are you asking this question? What is P? My probability that this person has arthritis. 0.624. Weird, because normally we go 2 decimal points, but since this had a decimal place, you have to move it 2 positions to the left. So therefore, Angelise, what is Q?
Q is, 1 minus 26.
So what is that? 1 minus 2624. 376. Thanks, ladies. Okay, so do I have a binomial situation? Am I doing this a fixed number of trials? Does my probability stay consistent? It's fixed? Yes? Do I have 2 options, 2 outcomes? Yay, nay? Yep. So I have a binomial situation. So I'm going to write my probability statement. How do I say exactly 48? X equals 48. That's exactly. So before we had more than, we said greater than 48. We had at least, we had greater than or equal to 48. This time we have exactly 48, which means on your little thing, if this is the 48, I just have one little line. It's a discrete number. It has no area there. So for me to get an area, I got to make a bar around it. I got to make it into a bar. I got to give it some area. So what happens on the equal sign is it's going to expand in both directions. We're going to just take this and make it an and statement. We're going to drop it 0.5, and we're going to raise it 0.5. So where is the center of that bar? At 48. It has no area right now. It's just a very discrete number, one little pinpoint, one little point, one little straight line with no boundary, no area to it. So we're going to give it area. That's a decimal in there. Okay, so the second thing we had to do was we were supposed to test to make sure we could do this. Like I told you, they'll test correctly, otherwise you don't have a problem to do, but we need to test anyway. So we take our 75 times 0.624, and we check this. We take our 75 times 0.376, and we check this. This is the guy that we would probably check first. If the smaller one works, the larger one works. So they both pass the test, and this guy comes out to be 46.8. He is the mean, because the mean is n times p. So now I know the mean of my situation. The mean is 46.8, and now I can find the standard deviation. The standard deviation is square root of n times p times q. Well, I've got n times p, and I just need to multiply by q. So I'm going to find my standard deviation for this guy. And my standard deviation is 4.19 or 4.2. Let's go with 4.2. 4.19, 4.2, whichever one you give me. What is the book? I don't even know what the book is. Okay, so now, our next step, your discrete value, everybody's a discrete value. You can only have exactly 48 people that answer this. You will never get 47.5 or 48.5, but in your normal curve, because you said by doing this, that this binomial, I can use a normal distribution for this. It qualifies for this normal distribution. My normal distribution has area under that curve. So it says you need bars under this curve. You need decimal places in here. I need continuity in here because I use continuous numbers. Binomials use discrete. So that forces me to have to do this, make a bar out of this. So now all you have to do is do this thing twice. It's just your and statement. Find the z-scores, find the areas, subtract the areas. And we can use your calculator for this part as well. I'll do it on your calculator after we do this. There's no sample. This is your trial size. So we're going to set x 47.5 minus your mean 46.8 over your standard deviation. I didn't sketch, sorry. We're going to take the other guy minus your mean over your standard deviation. We're going to find your z-scores, and we're going to look up your area. Okay. Then we're going to find your areas, and what are we going to do to the areas? Once we find the z-score and we find areas, what do we do to the areas? Subtract them. So we want the one in between. Do you think this will be a large area or a small area? Small. It's just one little bar, isn't it? It's just one little bar. To find something exactly is difficult. If I want to say I need to know exactly how many of you passed the last test, or the percentages that you'll pass the next test, and I say exactly 16, then I need to hit it. I'm 16, or I lose. So those are the things we're looking at with the exactly. Exactly's are harder to get to. All right, so we are going to calculate this. Calculate the z-scores, find me the areas, and tell me the answer. And for those of you that like the calculator, let's pull up the calculator. Remember the betweens? The calculators are the nicest. So the between says my lower limit, 47.5. If anything else, get used to the calculator for this guy. 48.5. My mean was 46.8. And my standard deviation was 4.2. The betweens are nice. This does all your z-scores, subtracts your areas, and gives you a final answer. You just have to make sure you round this to 4 decimal places. So I'm looking at this guy. I look to the right. This has to go up to 10. So 0.091 if you use your calculator. If you don't use your calculator, did anybody get the area? 0.0880866. Thank you. So we're in the ballpark. We're in the ballpark. The calculator's a little bit more exact. You've got 2 rounding things going on. A few rounding things. We rounded here to those z-scores, and we looked up their areas, and we subtracted their areas. Okay. And it's going to be small. For you to hit it in exactly something, you got to hit right on the nose, or you lose. You didn't get the right answer, right? In the next unit, when we do confidence intervals, we'll take those exact things and we'll give them wiggle room.
So there's a way to get 2 different answers for this, is what you're saying?
Well, if you use the formulas, you're always a little bit off on the calculator. Sometimes the calculator comes out real darn close because if you got a z-score that comes out to be 1.5, there's no rounding.
So when you grade it, you have a certain range of answers?
That's why I want you to say calculator.
Okay.
So I know your answer on the calculator, what it will be, and I know what your answer will be when you have to look it up on the table.
So all you want us to say is calculator?
Well, you should show me your calculator step, otherwise you have no work. Otherwise, you don't have to show any of this. So I say, where did you get your answer from? If you just gave me that and you just gave me an answer, I say, where did your answer come from? You say calculator, you give me your calculator step. Also, what happens is, if I don't see what your calculator step is, and your answer is way off, everything's wrong. If I see your calculator step, and you put it down and you said, I don't know, maybe you didn't put this in right, and you looked at it and said 54.5 or something like that, and then I could see, and you would see it too. Because what happens when you use a calculator, you go on to the next problem, you clear out the one before it. And I can't tell you how many people say, but that's what I got on my calculator. I put it in the right way. But I don't see it, you don't see it. Maybe you missed How many times do I do my calculator and you say, wait a second, you missed a number? You know, you miss a number and it gives you a different answer completely. So it forces you actually to have to look at it to say, that's what goes in my calculator. Do we get this? By steps, I mean, for when they give you a problem like this, I want you to follow these steps. Write out this, determine if it's binomial. Put your probability statement, correct it for continuity. I didn't do a sketch here. Give me a sketch using your standard deviation and your mean. Do your z-scores or show me your calc step. One of those. Give the answer. I need to see your mean. I need to see your standard deviation. I need to see a sketch. You know, sketch this, put your mean here, do your standard deviations, and fill out and shade. You know, sketch and shade. I need to see all those parts. I'm sure they all work, otherwise they wouldn't have a problem to give you, because we kind of took care of that in the first part, when it had you just check to see if you could use this. I'm pretty sure all of these work, otherwise you'd have nothing to do. Number 18 is just finding, actually number 18 I think you just have to see if it works. And then the rest I think the rest will all work. It looks like they did. Otherwise you have no work to do. So it looks good. Okay? Alright. Now?
I thought it was, no, I did it last night.
Oh, okay.
No, last
No, it's